Good morning, students. Today we are going to see about Betraon. This is one of the particle accelerator. It is in the course of thermodynamics, electromagnetism, and modern physics. So this is that development of accelerator. It started in the year 1870. The William Crookes invented that cathode rays. After that, 1895, J. Thomson I discovered that electrons. After that, in 1896, Bronson discovered X-rays. After that, 1909, Rutherford did an experiment like scattering of alpha particle on a gold foil. After that, he concluded that inside that atom, more number of empty space is there. A small amount of positive charge that is called as nucleus. After that, in 1929, Evo Lawrence invented cyclotron. It is one of the particle accelerator. That cyclotron is used to accelerate mainly electrons. In 1931, Robert Semison Van de Graaff invented the Van de Graaff accelerator. By his name only it is called as Van de Graaff accelerator. After that, in 1932, John D. Cockcroft and Ernest Walton invented the Cockcroft-Walton generators. After that only, the Betatron is invented in the year 1940 by Donald W. Kest. So this is the definition of particle accelerator. A particle accelerator is a device which uses the electromagnetic field to propel the charged particles like protons, electrons to high speeds and to contain them in well-defined beams. So from this, we conclude that particle accelerator is used to accelerate the charged particles to high speeds. They built for different purposes such as radiotherapy, ion implantation, industrial and biomedical research. The basic principle of accelerator is as follows. All the accelerators are based on the same principle. A charged particle accelerates between a gap between two electrodes. In between the two electrodes, a potential difference is introduced here. So, this is the basic principle of all the accelerators. This is the type of accelerators. The particle accelerator can be split into two fundamental types. One is electrostatic accelerator. Second one is accelerating field accelerators. First of all, we are going to see about electrostatic accelerator. The examples of electrostatic accelerators are Cockcroft-Walton accelerator and Van de Graaff accelerator. So, which make use of electrostatic field, so that only it is called as electrostatic accelerators. Here, the electrostatic fields are simply electric field, but which do not change with time. So that only it's called electrostatic fields. The main disadvantages of electrostatic fields is that very large electric field need to be generated to accelerate the particles to experimentally useful energies. By output of this, we are getting useful energies. The next one is that accelerating field accelerator. This type of accelerators requires electric fields which periodically change with time. So, it has allowed high energy physicists to accelerate the particle to extremely high energies. So, these are the types of accelerators. The main categories of particle accelerators are detailed below. First one is that Cockcroft-Walton accelerator, Van de Graaff accelerator, linear accelerator. It is simply called as LINAC. Cyclotron, Betatron, Microtron, Synchrocyclotron, Synchrotron, the storage ring collider. So these are the types of oscillator used in many applications. So first of all, we are going to see about the invention of that Betatron. The Betatron is invented in the year 1940 by Donald Kirst. The development of Betatron was driven by the demand for high energy X-rays and gamma rays. So in this diagram, the Betatron, this is the Betatron main ring. Here, this is a donut shaped vacuum chamber. This is the donut shaped vacuum chamber known as donut chamber. So the 3 is the donut chamber in which electrons are produced by a electron gun. Here, this is the electron gun. In this way, here that electrons are produced. Next is that it is within the chamber, the electrons are accelerated. So inside the chamber itself, the electrons are accelerated. This is the principle of Betatron. It is same as that of the principle of transformer. In transformer, if an alternating current is passed through the primary coil, an alternating magnetic field will appear in the coil. This field produces an induced EMF in the secondary coil. This is the principle of transformer. Similarly, the changing in that magnetic flux induces an electromagnetic field which is acting tangentially along the circular path of the electron, so that these electrons are accelerated to high energies. If the electrons are kept accelerating in a circular path of constant radius by the help of increasing magnetic field. So in that diagram of Betatron, there will be a chamber is there. The chamber is set in between the two poles of the electromagnet. The electromagnet is driven by an AC current, so that it results on constantly changing magnetic field. The changing magnetic field means a changing magnetic flux across the donut chamber that produces an electromotive force which will accelerate that electrons. This is shown in that diagram. The electrons in the chamber maintain the constant radius of orbit while it is being accelerated due to the centripetal force generated by the particle motion. Once the electrons are accelerated, the electrons are directed out of the donut chamber or towards the metal target to produce the X-rays. That X-rays are mainly produced by the incidence of electrons on the metal target. So here also that electrons are directed and towards the donor chamber, and it is incident on the metal target so that the X-rays are produced. This is the working of an Betatron. Here, when the electrons appears at cathode in the donut tube and the electromagnets are energized, that the magnetic field is also increasing. The increasing in the magnetic field has two effects. One is that the induced EMF produced in electron orbit by changing the magnetic flux gives an additional energy to the electron, so that by getting that energy, the electrons are accelerated to high speeds. So by using that Faraday law, the induced EMF equal to minus d phi by dt. Here, phi is the magnetic flux. This is the changing magnetic flux which will give an additional energy to the electron. So, while the electrons traveling in that circular orbit, one radial force is produced by the action of the magnetic field. So here the magnetic field is perpendicular to the electron velocity, and it keeps the electron moving in a circular path. The force is balanced by the centripetal force. Here, that Lorentz force is produced. The Lorentz force is expressed by F is equal to PeV. Here, B is the magnetic field. V is the velocity. Due to the magnetic field, the velocity of electron have to be increased. Then Q is the charge of the electron. That force is equal to centripetal force. The centripetal force is mv squared by r. So next, the particle acceleration occurs only with increasing the flux. That increasing the flux taken place in the duration from 0 to maximum value. So that is that the first quarter of the AC cycle. So that is expressed times equal to T by 4 seconds. After this, the flux starts decreasing, which results in decreasing velocity. Therefore, the electron is kept in the tube only for the time of T by 4 seconds. After that, the electron get faster velocity, and for that they need a larger magnetic field to keep moving at a constant radius. So here the large magnetic field and that it provides that higher velocity for that electron. So here this will be that working that in the diagram there are two downward chamfer is there. So here the main flux is produced upwards. Here it is connected to a magnet. Here, due to the magnetic field inside, the main magnetic field flux will be produced. So it is expressed by a diagram. Graph is shown here. It is drawn between time and the flux. When the flux increases to a maximum value, there will be a ejection of electrons. Here at t is equal to 0, that electrons are injected into the chamber. The flux reaches the maximum value. After that, there will be a ejection of electrons from the chamber, and they are accelerated to a higher velocities. So that the acceleration is explained by using this. So next is that so the beta condition is explained here. So the induced EMF from the coil is explained by the Faraday's law of electromagnetic induction. So that EMF is equal to minus d phi by dt. The work done on an electron in one revolution is explained by W is equal to EMF into charge of electron. Here W is equal to E d phi by dt. The work done is equal to tangential force on electron into distance traveled in one revolution. Here W is equal to F into tangential force into 2 pi r equal to E d phi by dt. Then F is equal to E by 2 pi r into d phi by dt. Here, the electrons move in a circular path. The magnetic force is balanced by centripetal force. So that we can write that force EVP is equal to mv squared by r. mv squared by r is the centripetal force. So here we can equate that equation. You can simplify that equation that V and V will cancel out. We can get EBR is equal to MV. Here MV is that momentum. Momentum is equal to mass into velocity. So next is that by using that Newton's second law of radial force, F is equal to dp by dt. So F is equal to ma is that Newton's second law. So we can take this as ma is equal to m into dv by dt. So by using that we can write here. So F is equal to depr by dt. So then, in order to maintain the constant radius, the force is equal to, we have to differentiate these equations. Then, equating that equations, F is equal to ER dp by dt, and we can get that equation in the previous one. So, E into 2 pi r d phi by dt. So, we can get that the flux with respect to time is equal to 2 pi r square dp by dt. By integrating these equations, we are getting that 2 pi r squared into v. So this is that called as that Betraon conditions. I will derive that once again. So I will derive that equations for the Betraon condition. Here I will derive that. So here that EMF is equal to EMF. EMF is equal to d phi by t. This will be the change in flux, magnetic flux. That will give an EMF. So next is that by introducing a magnetic field, so the magnetic force is produced, that is given as PVQ, that is equal to mv squared divided by r. That is equal to the centripetal force. Now we are going to derive that Betraon condition. So we can take by using that Faraday's law, the EMF is equal to EMF is equal to minus d phi by dt. Then the work done anion electron in one revolution is given by work done is equal to EMF into charge of electron. Charge of electron. So here this is equal to the charge of electron is E. The EMF is already we find that this is minus d phi by dt. This is the work done on an electron in one revolution. Then we have to go for the next one, that is work done, that is equal to, so the work done equal to the tangential force on electron into distance traveled in one revolution. So next is that the work done W is equal to the tangential force equal to force F into the distance traveled by one revolution. It can be written as 2 pi r. So this is equal to the already we derived that equation for work done E into d phi by dt. So by using this, we can derive F is equal to E by 2 pi r into d phi divided by dt. Here, the electron moves in a circular path. The magnetic force is balanced by centripetal force. So here the magnetic force is EVT. So it is balanced by centripetal force mv squared by r. So from this will be written as, so this v and this v will cancel out. So b will come here. So this can be written as EBR is equal to mv. Here mv is equal to momentum p. P is equal to EBR. Next is that from Newton's second law. From using the Newton's second law, F is equal to dp divided by dt. So this is equal to differential of mv divided by dt. So here instead of mv we can substitute d by dt of ebr. So here mv instead of mv you have to substitute ebr. Then in order to maintain constant radius. So here the electrons are moving with their constant radius. Here R is a constant. So by using this R is a constant, so you take outside, R is a constant, you take outside. Here E is the charge of the electron, that is also a constant. So we can write this F is equal to ER into dP divided by dt. So next is that here that P can be written as E by 2 pi R into d phi by dt. So from this we can calculate d phi by dt is equal to, so this you can write this d phi by dt equal to 2 pi r square into dp by dt. This e and this e will cancel out. This r will come here, 2 pi r square dp by dt equal to d phi by dt. So this is that by integrating this equation. So then we have to integrate that equation. So the next one. So here we are getting the equation as d phi by dt equal to 2 pi r square dp by dt. So then integrate this equation. Integrate the equation. We are getting, so if we integrate d phi by dt is equal to 2 pi r square. These are all constants. So you take outside, we are getting dp by dt. With respect to t only you have to differentiate. So we have to respect to t only you have to integrate. So here we are getting phi is equal to 2 pi r square into 2. So this is the Betraon condition. This is the Betraon condition. So this condition shows that the electrons in the circular path, it's moving in the circular path if the magnetic field is uniform throughout the orbit. Then only the electron can move inside that circular path with constant radius. So we have to maintain constant magnetic field. Then only that magnetic field will not increase. So here the electron will maintain in a circular path. Next is that the energy stored in the energy stored by the electron. You have to calculate this. So here the particle, that is electron, have maximum energy when the magnetic field is the strongest value. But this will be used to find out the rest mass energy of that electron. So here the energy is equal to momentum into, this is the velocity, momentum into velocity. Then as the centripetal force again provided by the Lorentz force. Here as the centripetal force is provided by again provided by Lorentz force, so that the momentum of electron will becomes, so here that Lorentz force is E B R. This is equal to mv. So already we have that equation. This is equal to P. Now the energy can be written as P into C. So E B R into C. This will be the energy gained by the electron from the Lorentz force. So that will again provided by the centripetal force. So this will be the energy. So the next one is that number of revolutions taken by an electron. So in T by 4 seconds. So this will be that in up to this seconds only electron has the maximum energy and maximum speed. So the electrons takes n revolutions and it moves in a constant radius. Then the total distance traveled can be written as the total distance traveled is S is equal to N. N is the number of revolutions. So after that N revolution, it reaches the distance as 2 pi r. So N into 2 pi r is equal to that velocity into time, that is equal to that distance travel. This is also a distance travel for n revolution. This is this will be the velocity of electron into t by 4. So from this, n can be written as n is equal to c t divided by 2 pi r into 4. So this will be 2 pi r into 4. So this will be written like this way. So here that n is equal to c by. So here 1 by T is equal to F, frequency. So this T can be written as C. We can put as it is. So here 1 by T. So instead of this 2 by F R into 4, we can write this is that. This is the n value. This is the number of revolutions per second. So next is that the average energy gained by an electron. So this can be written as E average is equal to the energy, the total energy gained by electron divided by the number of revolution taken. This will be the total energy gained by electron divided by number of revolutions taken. So this is the energy, average energy gained by the electrons. So by using this, we can calculate that Betraon condition, how much energy is gained by electron while it is traveling through the circular path, and the average energy gained by electron is also calculated. Next, so from that, we calculated the Betraon condition. Energy gained by electron is also calculated. The number of revolution taken by the electron is also calculated, and the average energy gained by revolution also calculated. So that Betraon is also a particle accelerator. This is some of the applications of particle accelerators. So first of all, it is used in the semiconductors industry. The semiconductor industry relies on accelerator technology to implant the ions in silicon chips, making them more effective in consumer electrical property products such as computers, smartphones, and MP3 players. So it is also used to clean the air and the water. So studies show that the blasts of electron from the particle accelerator, it is a useful and effective way to clean up the dirty water, sewage, sludge, and polluted gases from smokestacks. And for that medical diagnostics, that accelerators are needed to produce range of radioisotopes for medical diagnostics treatments that are routinely applied at hospitals worldwide in millions of procedures annually. And it is also used in shrink wrap. The industries uses particle accelerator to produce the sturdy, heat-stringable film that keeps such items as turkeys that produce and backed goods like fresh and protect the board games, DVDs, and series. And that particle accelerators are useful in the DNA research. The synchrotron light sources allowed scientists to analyze how the ribosome translates DNA information into life and earning them the 2009 Nobel Prize in Chemistry. Their research could lead to the development of new antibiotics. And these particle accelerators are used in the cancer therapy. And it comes to treat the certain kinds of cancer. The best tool may be particle beam. In hospitals that use particle accelerated technology to treat the thousands of patients per year with fewer side effects than the traditional treatments. So these are the some applications of particle accelerators. So that particle accelerators are used in DNA research, cancer therapy, medical diagnostic, and shrink wrap, clean air and water, and semiconductor industry also. This is very, very useful. So in this slides, we saw about the construction of the Betraon, how the Betraon is working. So from this, we are using that phenomena that Betatron works like a transformer. In the transformer, there are two coils is that one is the primary and the secondary coil. Here, the current induces the magnetic field. That principle is used here also. So from that previous one, we have to calculate that Betatron condition. The Betatron condition is derived from the Faraday's law of electromagnetic induction. The Faraday's law is the EMF is equal to minus d phi by dt. From this, we can calculate that work done of an electron for one revolutions. So here the work done have to be calculated, and by using that Lorentz force there will be a work done is produced. We have to equate these two. We are getting that force. From this, we can calculate that flux. The flux is equal to 2 pi r squared into B. From these conditions, we can conclude that electrons moves in a circular path of a constant radius. The magnetic flux within the orbit of radius is always twice what it have been if the magnetic field were uniform throughout the orbit. So to maintain that a constant radius inside the donut shaped material, here the magnetic field is also uniform throughout the orbit. And also from this we can calculate that energy gained by the electron. The energy gained by the electron is equal to EBR into C. E is the charge, B is the magnetic field, R is the radius, C is the velocity of the electron. So here the energy gained by the electrons depends upon that magnetic field. The magnetic field is given to the betatron is more means the energy gained by it is also high. So from this we can calculate that number of revolutions taken by the electron. So that is equal to C by 4 pi omega r. So here the number of revolutions also depends upon the velocity of that electrons. So from this we can calculate that average energy gained per revolutions, that is The average energy gain per revolution is equal to the total energy gained by an electron and the number of revolutions taken. So at last we saw about that uh, applications of particle accelerator. So by this you can know about that Betatron very well. Thank you for listening.